In the previous video, we talked about this is the analog system using a Laplace. You can either Laplace transform into a Laplace domain, or you can state space into the Laplace domain. Alright, nonetheless, in the digital domain, you can from Laplace to the Z system, you can Z transform, or otherwise you can also use a state space to go into the Z domain. Alright, so in order to prove to you that the Z transform in answer is the same as the state space answer, in this purpose of this video, I'll do the Z transform first, to give you a certain answer. So in the next video, we'll use a state space to actually see whether are they the same. Okay, so let's start off with this thing. I'll Z transform first using a 0th order whole. Alright, let's go. So imagine I have a certain transfer function called 1 over s squared. Okay, so how do we Z transform using this 0th order whole? Alright, especially this term over here tells you the 0th order whole. If you don't know anything about 0th order whole, then I'll suggest you should watch this 6 videos in my playlist. Alright, and therefore this is the thing that performs the 0th order whole transfer function. This is like a general equation. Okay, so therefore I'll just simply maybe I should rewrite lah. Hold on a while. Alright, so I have this thing over here, the transfer function. I put it over here because it's transfer function over s. Or you may wonder why I ignore the Laplace, inverse Laplace to transform. It's because there's a shortcut. Alright, and I'll not go into there. But anyway, so normally you want to do this lah. Okay, this is the one of the way to do this, not the standard way, but one of the shortcut method. Okay, so over here you may feel tempted to actually write it as 1 over s squared times divided by. But anyway, I have a careless mistake that I'll cancel this with this. Alright, so I have 1 over s. No, don't do this. I'll be careful, because 1 over s squared, if you divide it by s, why am I shaking the tablet? Anyway, hold on a while. Okay, so divided by s. Alright, so divided by s, if you change it, you have a times 1 over s, so it is equals to 1 over s cubed. Alright, so this thing over here, be very careful when you do this, because this is my class mistake. Anyway, so eventually I would have my transfer function interacting with the divided by s. So this term over here, alright, becomes this term 1 over s cubed by g over s divided by s. Alright, so therefore the next step now, z transform this thing. Okay, and in fact use this table. Alright, it is tabella transformata anyway, so you can just download this file. Alright, or it's inside your file if you happen that you have, or you can go Google search, I think have. So this thing over here is related to my s cube, but this thing over here is 2 over s cube is equals to the z transform of this thing. Okay, so therefore 1 over s cube is this thing over here divided by 2 lah. Okay, so this thing over here will be 1 over s cube. So this thing is equals to this thing. Alright, so by 1 over s cube, I can simply rewrite as this, but be careful of the 2 lah. Okay, because this one over here at first was 2. Right, so you have to switch it to 1. So if you, in other words, I bring this thing, I bring it over here, I bring this thing, I bring it over here. Okay, so they are equals to each other. And in the case that you forget in the future, alright, is that this thing over here is the time domain t squared. Alright, this thing over is in the discrete domain. The time domain itself is an analog signal. The discrete domain itself is a dot by dot by dot by dot. A digital domain, especially for this, is a 0. I think, yeah, some z system. Alright, is in terms of some digital signal. Alright, where you connect the dots. Alright, and this thing over here is just a Laplace in terms of a Laplace domain. That's all. Okay, so therefore in case that you forget in the future, but anyway, so this thing over here, I set them equals to each other. Alright, in other words, I bring this one over here, I bring this one over here. Alright, so therefore if I were to do that, alright, this thing over here I can bring it down. Alright, so I will have 2 and I cancel off this one, right? So I have 1 over s cubed, because our purpose over here is 1 over s cubed ma. Alright, so I just want to z transform 1 over s cubed into this thing now. Okay, so hopefully you understand what I mean now. Alright, so therefore let's just continue and see how it goes, right? So and therefore I can write sorry, where's my pen? Yeah, 1 minus z minus 1. Alright, you may be tempted to write z again and then you sub in this thing. Alright, you may be tempted to do that. Don't do this. Alright, don't do this, because this thing is not z. This is one set telling you that you're gonna z transform this thing. Okay, so this thing over here is not a z that you're gonna include in the future. Alright, so this thing over here is just to indicate that it's going to be transforming. So after transformation, you become this thing. Alright, this thing over here, I repeat again, is a indication that you're gonna z transform 1 over s cubed. Something like a Laplace, maybe ft, if you happen that you find it familiar. You Laplace transform this thing, you become some other arbitrary s square. You don't include the Laplace L like that or together with it, right? So therefore this is something that you may have to be very careful with. Alright, so nonetheless, if I z transform this thing, 1 over s cubed, you have this thing over here. Okay, so let us just see what we can do to make it more simpler. So over here, this is 1 minus z minus 1. This is 1 minus z minus 1 also. And therefore I can cancel this with this. This one becomes square. Right? This is cube lah, if happen that you cannot see. So this is square now, because I cancel away. Okay, so what I would have is, I would have this thing. Alright, but it's not very nice because it's z to the negative 1. Alright, if it's not very nice. I want it to be like 1 over z, because z negative 1 is equals to 1 over z. Alright, it's inverse. Alright, I think you know what I mean. Alright, like 1 over 2 is equals to 2, this one. You can type it inside a calculator, you prove yourself. Alright, anyway, so I can rewrite this z minus 1 as 1 over z. Okay, I can rewrite all the z minus 1 as 1 over z. So I will have this thing. Ta-da! So therefore I can just expand this thing, square. Alright, have this thing. You can own self go and try it out, write it on paper. This thing over here is this thing. Okay, it's just expansion only. Alright, and I'm gonna rearrange this thing because everything is 1 over z ma. I want to rearrange stuff. So I'll just multiply with z over z. Okay, so if I had to multiply it in, this z over here, I'm gonna multiply with this z. Alright, 1 over z. Alright, actually I should multiply with z square. Okay, I should multiply with z square. You know what I mean? Because 1 over z, if I have to put it inside, I'll have 1 over z plus 1 over z square. Alright, so the highest is z square. Alright, so I want to multiply things to make this thing flat. You get what I mean? I'll just expand this thing first. I'll just multiply inside. Alright, so you can see better. So I have 1 over z plus 1 over z square. Okay, so I'll replace them using this thing. Okay, so I'll cancel this thing off. I'll cancel this thing off. Okay, so this thing nice. Alright, so you want to rearrange stuff, make sure you multiply. This thing over here is equals to 1. Alright, so this thing over here is purposely to rearrange the fraction because the highest order is z square. So whenever you see the highest order, identify the highest order first, then you multiply with something that is in terms of its highest order, so that you can remove the fraction all over. Okay, because z square times over 1 over z square, you will get 1. Alright, z square times 1 over z, you will still get a z, which is not a fraction ma, so it's nice what, right? But anyway, so we just multiply z square with this thing and this thing. Alright, same thing over here, I multiply each of them all along. Alright, I'll not go through the step, you can also go and settle. What we have is, have this thing, okay? This thing becomes this one, okay? Wow, this thing over here becomes this thing. Alright, you just see z square times 1 is z square, and then z square times 1 over z square is 1, z square times 2z is 2z. Alright, 2 over z, sorry. I think you get what I mean, it's just subbing in only. Z square times 1 over z is z. Z square times 1 over z square is 1. Okay, things like that lah. Okay, so I see this thing is a potential form I can somewhat summarize or somewhat make it smaller. So what we have is about z minus 1 square. If you expand this, you eventually get this thing. Okay, trust me lah. So I will have this thing as my transfer function in the z domain. Okay, so this thing over here is my answer, and in the next video I'll use a state space just to update what I'm doing just now. Alright, just for the past 8 minutes, I think 9 minutes, is z transforming a certain transfer function g of s into a digital transfer function gz. Alright, the answer is the one that is this thing over here. Alright, we get an answer from here already. Alright, I'm gonna use a state space in the next video to prove that the state space answer is equals to the answer that we have just found out. Okay, so therefore in the next video we'll talk about designing a digital state space. Alright, so see you there.